Okay, so let's see, Hunter, you're sharing. So right now we are all seeing Hunter's screen. Okay, so this is what I want to try something. Okay, so just give me a second here while I get. Okay. All right. So as you're getting started here, I want to direct your attention to the screen here. So what we're seeing is we're seeing the screen. Hunter, I'm actually writing. I'm gonna write on your screen. Okay. So the display that my open math is using a little bit of different format to write the vectors. Okay. So first they're using this thing to enclose the vectors. We typically we've been using these for columns, right? And we've been using these for rows. Like the rows are horizontal, the columns are vertical, like that. And now they're using something that looks similar to the symbol that we're using for span. However, this is not a span. This whole thing is simply a row vector. So what we need to is to translate this into column vectors. So in this question, it says it has -2, 4, and -2. And then the other vector is -1, -3, and 3. Okay. And so the idea is which of the following, and so it gives you a list there. Which of the following is a member of the span? So it's asking for thinking of this set of these two vectors, and then think of the span of this set. In other words, the way you answer this question, the way I need everybody, these are very simple questions, but I need you to write down how you find the answer, right? And then you would have, if you click under written example, you'll see a display, but what you would do is you would propose, right, to a candidate, okay? You would propose a candidate to be written as a linear combination. Let's say this is something that looks like alpha 1 and you want this to look like alpha 1 and alpha 2. Sorry. Right, and this is alpha 1, alpha 2 of these members of the set that you're considering the span. So you have -2, 4, -2, and then -1, -3, 3. So you're wondering, can we represent the candidate member as a linear combination of the two members of that set under consideration? So I think Hunter already answered. Of course, here you can just check and click, and then this will tell which is the correct answer. But I'm saying that I need you to write this. So I'm gonna choose another one, right? So for example, is this vector -5, -6, and -12? Is this vector a linear combination of those two vectors? And if it is, that means that something happened there. Okay, I think Hunter is displaying the written solution, which is something that all of you can do. I wouldn't, after today, you can go home and then you can play the video. There is a video for each of the questions. Basically, in the video, they're going over what I'm going over with you right now. So, but if we propose this for the last option, then this becomes a system of linear equations, right? So what we would like to know is what are the values of alpha 1, alpha 2? Just think of alphas as, think of alpha 1, alpha 2 as x1 and x2. So we are interested in a solution set. And that means, what do we do to find the solution set? What would be the first thing we do? We would row reduce, but before row reducing, we need to form an augmented matrix, right? And so the augmented matrix, this would be column 1, this would be column 2, and this is the candidate member, the member we're deciding is this a member of the span or not, that would be column 3. So we would form that augmented matrix and row reduce. So Hunter, can you open another like a browser or another tab with one of, oh, you have it there, linear algebra toolbox.
But isn't there, the thing is saying to solve it for a y variable. Like, for example, in the written example, it's saying to set it equal to make it
Right, but let's go back.
go back to straight here.
To the question.
Mhm.
Yeah.
So
Don't worry about the written example right now.
Just-
So let's do it. In fact, everybody can, for the sake of exercise, you don't have the identical values that Hunter has, correct? Everybody has, or everybody has the same values?
no.
No? But choose the last one. Do exactly what I'm doing. Choose the last one as the candidate. You suspect it's probably gonna be a no, right? But choose the last one as the last column and row reduce. Okay? So okay, Hunter, so that you need to create a matrix that has 3 rows and 3 columns, and you want to, the third thing, transforming a matrix to, no, not this one, that one. So m equal 3, n equal 3, and now there you go. Okay, I think Hunter, hold on. If you hit submit, you should get an error. It doesn't like it. Go back. Okay, you are also, see, this is Brandon, this is what you were saying, right? So what you write on the third column is the candidate. So right there, -5, -6, and -12.
I think you missed the negative.
Okay, all right. So I missed a negative. Yes, where is the negative?
The one in the second vector.
In the second column. Good catch. Good catch. Okay. So let's check these columns again. All right. So the first column is -2, 4, -2. That looks good. The second column, almost there. The first entry of the second column is -1. Okay. So what would this tell us? Yeah, somebody's writing me. So I can use another color. So very importantly is that this is the augmented matrix, right? So this matrix of coefficients has 2 columns, right? So this last row is bad news because this last row has a 1 in the last column, right? So that means 0. This implies basically 0 equals 1, which is a contradiction. And that's what you would use to argue that the solution set we were looking for is an empty set. So that solution set has no members in it, which means that these values of alpha 1 and alpha 2, they do not exist. It's not possible. So in other words, is this set a member, is this column -5, -6, -12, is this column a member of the span? No, it's not a member of the span, right? Now you repeat this procedure with each of the candidates and let's see what you get. So I know that You probably already know the answer, but let's road reduce with every single one of those candidates, and let's write down what is the RDF and write down what you conclude. Let's say, let's take 5 minutes.
Okay. Do we need to do the RREF by hand, or can we use the?
No, use the calculator.
Okay. Oh, just do one RREF by hand.
You can do one by hand. Yes. They're not too long, right? They're just 3 by 3 or.
So you want us to show first row for 6 and 5? Just
Need to use a calculator. Oh, you want us to have it? Well, it's like, we can just, if you do it, ask me to. So, did we use green for the first question?
So,
Yeah, but if you get the numbers, you didn't give me that green.
Hunter, would you mind to stop the sharing? Okay, now I can. I was a little lost because I didn't know where the chat was. Okay, Aaron, will you be able to share your screen for the next question in my open math? And we can do what we did with Hunter, that I can annotate your screen. Yeah, okay. So just be ready, Aaron. Just open my open math and excuse me. Also, Aaron, you're gonna need, like Hunter, you're gonna need something to row reduce, either Wolfram alpha or something like that.
Which one is this the comprehension spanning vectors?